Hey everybody, welcome back to another Wizards Lizard 2 game development live stream. I'm Jeff from Lost Decade Games, and today I think we're going to be working on a little bit of enemy behavior, perhaps. Something I've been thinking about working on today. And I'm going to take a little bit of a different approach, I think. Been messing around with some physics-based stuff in Unity up until now. But I want to try a little more controlled setup with the enemy behavior, something maybe involving tweens and tile-based movement. So we will see what we can get done. Um, also, a little bit more work has been done. Ooh, let's turn the audio off for now. A little bit more work has been done on what is the kitchen environment. Matt did a great job on the walls and stuff, and then I've been kind of tweaking it a little bit to feel more kitcheny with some of the props that Matt has drawn as well. So let's see if we can find some of those in this labyrinth of a level. Now we got some tables. Here's a table with a pig, stuffed pig on it. We can also kind of zoom out. Oops, here we go. Take a look at our level. We got some tables with turkeys, pigs, kind of strewn about the various areas in the kitchen. So that part's coming along. But now I want to create some enemy behavior. And like I said, I'm going to start with a simple tile-based movement enemy. Maybe like even a trap. Maybe it's not something you can kill. Something that just moves kind of along the tile grid. Which is really just the Unity grid, actually, which is going to make this kind of easy because the tiles here in a Wizards Lizard 2 are all one Unity unit in width and height. And so that should be hopefully pretty easy. Let's get started. I think the first thing we're going to do is we're going to make sure we're all up to date with the graphics and such. And then we will first let's just create the kind of base game object that's going to serve as our enemy. So I think the first thing we're going to do is just load up our test scene, and then we're going to pick something to represent our enemy for now. And let's see. See if there's anything that jumps out at me real quick. The idea here that I'm having is like something like a floating kitchen knife. I guess I could just use a sword for it. Yeah, that would work. So let's see. It's 100 pixels per unit. So that's about right. I think this is more like 80. This is about the scale these were drawn at. So we'll just save that. Multiple sprites, it's all good to go. Maybe we'll use this thing in the middle since it looks kind of like what one might think of as a kitchen knife. So we'll grab this guy, we'll drop him into the world, and call this knife. So the idea here is that the kitchen is cursed and it's got some animated stuff like dancing sword style stuff going on. So we got the sprite. We want to render probably as a tile object, which is pretty much the layer that all of our entities that need to be sorted correctly are on. And so right now let's put it at, let's say 2, actually 0, no, 2, 0. And then I should actually put it next to the player. Hey Joe, welcome to the stream. Joe says that he left Games Done Quick to watch me instead. That's how much he likes my stream. I am honored because Games Done Quick is really cool. I think both Matt and I have been kind of catching some of those off and on. and it's pretty impressive level of skill and dedication that those guys have. So cool, and glad to have you. Anyways, I want to put this knife thing on a specific tile because what I want to do is I kind of want to have it move like from tile to tile on some kind of increment. So I think that what we're going to do first is we're going to create a script, and we're going to call that knife, perhaps. And then we'll open up in Sublime Text, because that is our favorite editor in the world. And so, let's see, I think that what we want to do here is basically create a timer and have it move, or actually we're going to have it tween to a location every so many seconds, just to kind of get like a very kind of methodical movement to it. Hey, Mudgrunt, thanks for joining the stream. So I think the first thing we're going to do is on start, we're going to implement something here. Maybe we're going to call invoke. We'll call it, let's call it move for now. And we'll invoke that right away, 0 seconds. Actually, I could just call it. That's probably a better idea. We'll call a move function. And then we'll have this be a function. And then for now, just to keep it simple and make sure that it's working the way we want, we're going to do this in steps, obviously. And so ultimately we'll get to a point where there's, it's respecting the walls and it doesn't try to move into a wall. It's going to be smart enough to kind of turn around and stuff like that. But for now, we're just going to make sure that it actually does what I want it to do. We're currently using LeanTween, which is a tweening library. And what we can do is, so you can say move X. And I'm actually going to have to look up documentation for LeanTween real quick. That is not what I wanted. This is what I wanted. Just because I forgot what the parameters are here. Move X. Okay. Okay, so it's just a flip. Great. So we're going to pass in the game object that this happens to be, and it's going to start at 2. Actually, really what we want to do is just kind of have it move to the right. So we're going to say transform.position.x plus 1. And so I'll just keep it moving along that axis, and we're going to say we want this to happen over 1 second. And then the next thing we're going to do is we're going to invoke move again, and we'll say 1 second. So we'll get kind of a 1, 1, 1, that kind of thing. Hopefully, assuming that this actually works correctly. And then the last thing we have to do is actually add this component to the prefab, or to the game object rather. Oh. So it's actually moving more smoothly than I wanted to, and I think it's because we either need to reduce the time it takes to tween there or increase the interval between when it moves. There we go. And we can also put a nicer easing on there, so we can say LeanTween type, I think. Is that what it's called? LeanTween, yes, LeanTween type. And let's do ease in out sine wave, just for now. Ease in out sine. Let's see what that looks like. There we go. It's kind of hard to see the actual difference, but that is the general idea. So now a couple things we want to do here. One is that we want to make it so it goes other directions, and I think the way that I want this behavior to work is that it's going to keep going until it hits a wall, and then it'll change directions based on a direction that actually has nothing in the way. And so I think the way that we're going to do that is through ray casting. But first, let's get some randomization in here. So when we do move, so I think the first thing we need is we need to store the direction that it is moving, and we're probably going to store that as a vector. So we'll have a, actually private now, private vector2, and it's going to be direction, and it's going to be vector2.0, which is just, an empty vector. And then to start with, we will say that it is, we're going to randomize the direction. And so we want to randomize the direction on an orthogonal axis, which means it can either be up or down. And I have this, let's see, this random. Do I want to use this random library that I wrote? I might. The other thing I can do is I can just use Unity's random. Although I just need to make sure that I know what the API is I want to use. I think I want to use value, yeah. So value is just a normal between 0 and 1. And it does look like it's sneaking away from me, as Joe mentions in the chat. The sword is trying to escape. So what we can do is do a simple chance here, so we can say if random dot value is greater than or equal to 0.5, then we'll say direction dot x is equal to 1, else direction dot y is equal to 1. And we probably want to set the opposites to 0 as well, since we only want it moving along one axis at a time. Otherwise we'll get diagonal movement, which we don't want. Hey, Pedro Mundo, thanks for joining. And yes, 90% of game dev is Googling stuff, as is most of programming, actually. It's kind of one of those things where, it's why interviews for programming positions are always kind of tough, is because it's impossible to keep all those APIs in your head all the time. The next thing we want to do is obviously flip these directions one way or the other. So what we can do is we can say if, again, random.value is greater than or equal to 0.5, then we'll say direction times equals -1. And so 0 times -1 should be 0, and then 1 times -1 is -1. So that'll basically flip the vector for us. And so what this is going to do, the other thing we're going to do is we're going to go back to our lean tween documentation. I think it's just move is the method that we want here. And then we're going to have to pass it a vector3, yes. Or we can pass it a path of vectors, that's kind of cool. But in this case, we just want to pass it a single vector3. So we're going to say, let's see, vector3 dot location is equal to new vector3, and it's going to be, actually, what we want to do is we want to take vector3 from the object itself. So this is going to be transform.position, which is going to give us the position of the object in the world. And let's see. Then we're going to add our direction onto it. So then we're going to say location.x plus equals direction.x, and location.y plus equals direction.y. Yeah, Joe says in chat that it's strange how random.value and it's not random.value with parentheses. It is pretty interesting. It's because it's like a value. It's like a property, I guess, but it's returning a different value each time. It's kind of strange. because it says listed here under static variables, but it's not actually a static variable. And all the functions are uppercase. We have someone else, Guy Mister. Thanks for joining the chat. He says, I'm watching Games Done Quick right now. Do you hope people get as dedicated to speedrunning these games as much as they are to others? Absolutely, yeah. That would be amazing if people would want to speedrun a Wizard's Lizard 2 as much as some other games. So that is the hope. And we hope we've learned a lot since Wizard's Lizard 1. We're going to try and make the game a little more friendly towards that kind of thing. It's not a terrible speedrunning game right now, I would say. It probably only suffers from the fact that it's not more popular. And so, it's hard for a larger audience to appreciate the speedrunning. Also, the thing with the Wizard's Lizard 1 is that I think the big hindrance towards speedrunning is the room-based approach, where you have to go into a room, you have to kill everything, and then you can leave. And that's not really an ideal situation for a speedrunning situation. Anyway, so let's just put this in a function real quick. And Cat is scratching the chair, which I don't want him to do. This can actually be a private function. And then let's make another function here. Private void, choose direction. And then right as we move, we'll call it choose direction. And so for now, it's just going to pick a random direction every time it moves, hopefully. And by random, I mean it'll just keep going to the right. And the reason it's doing that is because we're actually not using our location. We're still using this move x function. So what we actually want to do is call move, and then instead of passing in that, we want to pass in location, and everything else can stay the same. Yeah, that's another thing. Good point about the RNG stuff. However, the counterpoint to that is that games like Binding of Isaac and Spelunky have very big speedrunning scenes. And so, Spelunky especially lends itself to speedrunning, and there's a lot of randomization going on in that game too. So anyways, yeah, our sword's kind of doing what we want. This is just some basic enemy movement. It kind of feels like, like a slime or something, kind of just moving one tile at a time. One thing that I wanted to do here, though, and I don't know exactly how to approach it. I think what I'm going to do with this is split this game object into a couple parts, because what I want to do is I want to have it moving, but I want to give it this kind of like tweeny effect where it kind of pulses up and down, floats, if you will. And I think to achieve that, what we're going to want to do is actually create a nested game object. And this is something that I had not really seen the benefit of until I started working with Unity. But in our HTML5 game engine, we had an entity component system that, functions similarly to how it works in Unity, but we couldn't or didn't support game objects with nested children. That's actually a really powerful feature. Welcome to Josin86. Thanks for coming by. He says, hi, I heard you say you used lean tween. Have you tried do tween? I ended up using that because it seems to be more powerful, but I haven't tried lean tween. Is it any good? I've actually had do tween suggested to me on a couple of occasions. It does seem to be very popular, and it seems to be really performant too. The reason I chose lean tween was because it was the most minimalist and looked to be the most performant. It seems like do tween and lean tween have similar performance, and it was just one. It's open source and really easy to work with and free, and I think do tween is free too. But I kind of imagine they do about the same kind of stuff. And I've started learning lean tween, and so obviously I have to look at the documentation every now and again, but it does what I need it to. I may check out do tweening at some point in the future because I have heard that it is really good. I get all kinds of suggestions on my Unity stream for stuff to look into, and it's kind of hard to get to it all. So what we're going to do here is we're going to move the sprite renderer for our knife thing. Let's see, sword, there we go, to a different game object. And we're going to give it all the same properties that it had before, and then we're going to remove the sprite renderer from here. And so really, from here, we should have pretty much the exact same behavior. It's just that now I've separated the sprite into a subgame object. Let's see, catch up with chat. So Joe says, I think one cool thing about procedurally generated games is to give people an editable random seed like Minecraft, so you can replay the exact same world layout. Yes, I totally agree. This game is being built with that kind of a setup in mind. It's actually kind of a shame with the Wizards of the Lizard 1 because it is actually a seeded level generator too, and early on in the development, we had a feature where you could actually challenge someone. And that was kind of back when it was more of like a web-based thing. You could just send someone a link, and when you clicked through it, you could play the same seed that they were playing. Obviously, it doesn't work as well in a non-web environment, but you know, had we taken the time to really build out that feature and allow people to, one, see what the seed is that they're currently playing, and then send that to a friend, it would have probably helped a lot. But yeah, so seeded level generation is an absolute priority here. So the other thing we want to do here is I want to get a reference to the knife sprite. And so what I'm going to do here is I'm going to put a public variable, which is going to be a game object. And we're going to call this the sprite. And then what we're going to do when we start is we're going to say effects dot, let's see what it was. So I wrote this little effects library, and it does some cool stuff like flashing and hovering. Hovering is what I want. So I want to hover the sprite. And then back in Unity, all we have to do is drag this guy here. And so this child object is going to be floating in local space, I think. Hopefully, we'll see. Yeah. It looks sort of right. It seems to be a big delay sometimes, though. Whoop. Like right now. Like why is it a long delay sometimes? Let's do some debugging. So when we're choosing direction, we'll just say debug.log. We'll say direction.x plus a comma plus direction.y. Actually, maybe I can just say direction. I wonder if Unity's debugger is nice enough to do that for me. Yes, it is. Okay. So the times when it's going to the right, that's weird. So it's definitely stopping at some point and not going the direction I want it to. But it's never 0. So it's going to the right. It's not going up. So that is, yeah, so the issue is it's just not going up anymore, which is pretty interesting. I wonder why that is. So this sprite I think maybe what we need is for the floating algorithm to only operate on the local axis. I think that lean tween actually has a function for that. So let's check it out real quick. We'll check it out. Lean tween move local. There we go. So basically the same. What was it? Hash table. Hash optional items. I don't think we want to do that. It's a parent transform. Yeah. So to keep it simple, all I'm going to do is, let's see, is there a move local y actually? I kind of missed that. Between index. There's not. That's okay. So, anyways, what we're going to do is we're going to create another function here called hover local. And really, we want all the same stuff going on. And so we're going to say this is going to be local position, I think. And then we're going to say move local. And we're actually going to want a vector. The distance is going to be 0.5. So let's try this. Vector3 position is equal to, say, game object dot transform dot local position. And we'll comment that out for now. And then we're going to say that we want it to hover position dot y plus equals distance of the float, and then I guess that's probably it. And then all we have to do is give it to vector3, which is going to be position. Hopefully that's going to work. And this uses the ping pong setup for lean tween, where it just kind of goes back and forth. So really what we're doing is we're doing one tween that goes up half of a tile, and then it just kind of comes down with ping pong. So the ping pong takes it up and down, and then back up and back down. And so let's see, hover local. Let's see if that works. We will see. I kind of thought it shouldn't have been working that way before, but that does seem to work. Oh, I think I know what was happening. I think that the actual game object itself was moving in the right location, but the sprite was then decoupled from the local transform space, which made it appear like it wasn't going the right direction. So now we've kind of got it floating. And we can also increase that float, or rather decrease a little bit, so we could make it so that it goes a full rotation up and down. So right now it's going an up and a down in half of a second by default, and we can actually change that to be a quarter of a second, and then it'll go up and down in the same time that it takes to move one square. And so that might line up and look a little better. We'll see. It's hard to say. Oh no, that's the distance. Now it's moving less, which is really not what I wanted. I think it's going to be a second parameter, right? So hover local, yes, duration. Oh, so the duration is actually over 2 seconds right now. So this is going to be quite a bit faster, but we'll see what it looks like. See if we like the way it looks. Whoa. That's a much more energetic knife we have here. Oh, it looks kind of cool. The other thing we can do is we can send it in the direction that we want to go, or point it in the direction we want to go. And to do that, let's see, there's What else does that? The tongue does it, actually, the tongue sprite. Actually, not the tongue sprite, the tongue itself. There's really just a quick calculation we can do here, which is to take the angle and then rotate it by a certain amount of degrees. And so I think to get the facing, I think it's atan, right? Am I using atan anywhere? Atan. Lean Tween is used. Oh, here we go. Atan 2yx. Right. Atan 2yx. Okay. So what we're going to do here is, once we've chosen a direction, we're going to say the angle, float angle is equal to mathf.atan 2. Actually, it's going to be atan 2. And it's going to be the direction dot y, oops, sorry, direction dot y, direction dot x. And that should give us the angle. Joe says, I have never used atan before. Atan is arctangent, and it is the way that I get a angle around a circle from a vector. And so this is a normalized vector. And so, like, for example, in Unity, 0 radians is pointing to the right, which I think my webcam might be flipped, so I don't know which way is right and left. But it's pointing to the right, and so then, you know, the angle on a circle, like, so if you're pointing to the left, it would be 180 degrees. And if you're pointing to one of the other directions, that'll be, you know, either 90 degrees or 270 degrees or something. Or not 70. Yeah, 270. Anyway, so this should give us the angle, and then from the angle, we'll just copy and paste this little line here, which is going to, actually, we're going to rotate the sprite itself. Although rotating the sprite itself is going to mean that the tweens might get funny, but let's see what it looks like. So what we're going to actually do is say sprite dot transform around that angle. Let's see what it looks like. Nope, sprite does not exist because I spelled it incorrectly. So the only issue with this right now is that our graphic is actually drawn in the wrong perspective. So what we're going to do to account for that is just add 90 degrees or subtract 90 degrees, whichever is going to look correct. Okay, it looks like we're going to subtract 90 degrees, I think, because the sword sprite is actually drawn up and down. There it goes. So now it's kind of facing the direction that's moving. So that's kind of cool. I'm just going to kind of keep going along the along its boundaries. Oh, it's escaping. Hey, Evan Kurtz, thanks for joining. Glad to have you. So that actually works pretty well. I was kind of afraid that the tweening of the sprite of up and down, like the floating, would actually get affected by the rotation, but it doesn't really seem to, so that's good. That is good. I think we want to slow this down maybe just a little bit. It's a little too violent for me right now. I don't know, actually. Now it looks a little too slow. I don't know. We'll see. The other thing I kind of wanted to do was have it rotate, tween rotate to that, you know, kind of flip around. Instead of just like flipping, have it kind of tween the rotation to where we want it to be. So we're going to go back to our handy dandy lean tween documentation, rotate around the local. Rotate a game object. So I think this is what we're going to want to do. Lean, tween, rotate. And I think what we're going to want to do here is we've got our direction. In fact, actually, I should probably say degrees is equal. I'm going to pull this guy out here. And then we'll just get rid of this for now. And then we'll say lean, tween, dot rotate. And then we'll pass in the sprite again, which is the thing we want to rotate. And then I guess it wants a vector 3. So we're going to say vector 3. And we're going to want to rotate this around the z-axis, because the z-axis is what controls this kind of rotation in this particular coordinate system. So it's going to be 0, 0 degrees. And then we're going to want this to happen, let's make it happen quickly, over just a quarter of a second. And I think what I want to do eventually is kind of stagger that so it kind of rotates. There it goes. So now it kind of has a little bit cooler of a whoop, so it's flipping around. Yeah, I like that. The other thing I want to do though is kind of want it to pause. So what I want to happen is in move. First, let's create a different function called, well, actually, you know what we can do here is just say choose direction, and then here we'll invoke move after the same amount of time. Thanks, Joe. Joe says, looks awesome. It is very smooth. Yeah, the power of tweens, man. Tweening is where it's at. It kind of takes your stuff from looking rigid and unpolished to looking pretty good. So we're going to invoke the move function after a quarter of a second, which is the same amount of time it takes the sword to rotate. And so instead of calling move here, we're actually going to call choose direction. And then instead of invoking move here, we're going to invoke choose direction again. And so theoretically, what's going to happen is it will go nuts. Okay, well then. It's not exactly what I wanted to happen. Let's see, what did I... Oh, because, there we go. Now I need to remove that choose direction from move. We were getting into some kind of crazy, recursive craziness. So I think what we want to do here is maybe not call that for like another half second. So we want to rotate and then move. And so I'm actually going to take off the hover just for a second so I can make sure I know what's going on here. Right. Ooh. So that's kind of working the way I want it to now. Oh, where are you going? Come back down here. Nope. Don't run away. No, power of RNG. Okay. Yeah, that was kind of a crazy dagger. I was just flip-flopping all over the place. So this looks right. It kind of spins. And it's nice, too, because this provides a little bit of game mechanic warning, you know? So this entity is kind of telling you where it's going to move, and so you have a chance to move out of the way, you know? So I can follow this thing. Well, I can't follow it anymore, but I can follow it, and I will know which direction it's going to head. So I know I'm safe right here. No, I'm safe. Oh, I gotta get out of the way. Oh, there we go. And so we could actually restrict it to, so it could never flip around completely, right? We could say It's not just a completely random direction. It's only either straight or left and right or something. So that's pretty good so far. It's definitely making some progress. And I think the next thing we want to do, let's add our hover back in and make sure that that still looks the way we think that it should. Yeah. The other thing we could do is we can make this look a little more magical. And by adding particles to it. So let's do that, because that's also just fun. So we're going to add a particle system. Unity particle systems are great. They're really easy to work with. Anyways, here's our magical knife. And this is what the default particle emitter looks like. I'm going to change this a little bit to an edge. And then I'm going to actually change that radius a little bit lower to 5 even. Yeah, 5 is about right. About half of a width. I don't know, I kind of like the idea of it just kind of going up at the moment. And then let's make slow it down a little bit. And make them not last as long. There we go. And then maybe make them a little less. There we go. And then we're going to go into the renderer and we're going to not make it cast shadows or anything like that. And none of that other fancy stuff because we don't need that kind of stuff right now. And then I'm going to change the sorting layer to be a particle layer, which I created, which will make the particles be above this thing. And then let's make it have a color. Let's make it like purple or something, because that looks good to me. Yeah, that looks kind of magical. Or like blue, like a light blue or like a purple. Or green or orange. I'm kind of digging the purple. Make it like that. And then simulation space local, which is what we want, I think. Let's see what that looks like. Let's try world. I think that might actually look a little cooler because then it'll kind of have this almost like a trail, like where it's been, kinda. I don't know, it's a little more obscured now. I wonder if there's a way to we can do color over lifetime actually. And we can set the alpha value to 0 so they kind of disappear. That's a little better. So yeah, we've basically just taken a single graphic of a sword and turned it into, something that actually looks pretty cool. It's got some nice tweened animations. It's got a little bit of particle effects. And we can actually change those particles to be whatever we want. So, for example, we actually have, I don't know where I put them actually. Textures, particles. Yes, Joe says that sword's been hitting the hookah bong. I agree. Maybe what we'll do actually is, these are some particles from a Wizard's Lizard 1. And maybe what we'll do here is we'll just grab this guy, and we'll copy him to a new, well, we'll make this, let's make it 64 by 64. No? Really? 64 by 64? There we go. And then we will add a new layer, and we will delete this guy, and we'll paste in our particle. Oops. And then we'll like just center this guy. Sort of. Doesn't have to be perfect. Maybe we should scale it up though. I wonder if... I don't know paint.net all that well. So we're just not going to mess with that right now. All we're going to do is we're going to save this as, let's go into images, textures, and we'll call this purpleshine.png. Sure, why not? And then we're going to go and actually create a, so now we have this texture here, we're going to go and create a new material for it. And material, so this is going to be regular material. And we're going to call this purple shine. And then this is going to be a particle additive. And then we're going to select wherever it is. There it is, purple shine. So this is our shining particle now. And I think that for now that's all we need to do with that. We're going to go back into our particle system for the knife. And in the renderer, we're going to choose not the default particle, but our purple shine. There you go. And so you can kind of see, theoretically, unless I zoom in too much, that's what it looks like. So pretty cool. So that looks way better, much better. It's a little bit easier to see the sword, and also the particles just look much better because previously the default particles just kind of like a radial gradient circle, and so this looks much more magical and awesome. I am really happy with that guy. He looks pretty cool. So that's actually the easy part, sadly. The polish stuff is pretty easy to do. The next step that's going to be a little bit more difficult is kind of getting it to react correctly to walls. Which means we're going to have to put it in the world. And so the first thing we're going to do is we're going to create a prefab out of it. So we're going to go in here, and we have monsters or traps, I think. Maybe we'll call this a trap for now. I don't think it really matters at this current moment, but now we're going to delete that guy. And then we're going to set those guys to 0. So we have the knife. Yeah, Joe says the particles don't overwhelm the sword anymore. And absolutely true. Before it was just too crazy. So I pretty much never like using the default particle for that reason. Let's go back into our main level, and we're going to pull up our kitchen XML file that describes how the kitchen gets populated with stuff. And for this particular moment, what we're going to do is we're going to just comment out all this stuff, I think. Which is going to give us a lot of these things, so we're going to see how they act. So this could be another fun moment where things go haywire. We'll see. Hopefully not. So we're going to say the trap's knife. We can close this guy, actually. Don't save. And we'll go back to Unity. No, nothing? Really? Seems like... Oh, there they are. Here's some of our swords. So now they're kind of doing their thing. Running around the level. And it's actually a lot easier to see them moving on the grid in this particular case. Because you can see the tiled floor. Welcome back, Evan Kurtz. Yeah, I like that. That looks pretty cool. So the next thing we want to do is we want to put some colliders on them, and make sure that they respect the authority of the walls. And that's respecting the authority of the walls, like at a fundamental level, is pretty easy because once we put a collider on them, they'll just not, they won't clip through the walls anymore. So that part is good. But what we don't want is we don't want them to be trying to, like, keep going a direction that they can't go, essentially. So what we're going to do here is we're going to go put let's do a circle collider. That's good enough for now on this guy. And I wonder if the default is going to work here. Let's see. We're going to make those changes to the prefabs. Actually, you know what I should do? Instead of doing it this way, I can just bring those guys back. And then in my room populator, instead of having the sports ball here to play with, or actually including the sports ball, I can just add another line here, and we'll say this is going to be Y4, and we'll call this traps knife. Yeah, the swords are going to be enemies or traps. I'm not sure if they're going to be killable or not quite yet. I haven't decided, but someone was asking in chat if the swords are enemies. And then Evan asked, what kind of game is this? It is a action RPG kind of game. It's a sequel to a Wizard's Lizard, which is the first version of this game. It's kind of a action RPG roguelite game, and so this is going to be a very similar game, but much better, obviously. So we've got the box collider on this thing, but it's not colliding with walls, and that is generally because it has its collision layers not set up to collide with the walls correctly. So I think what we'll do is we're going to change this guy to be a solid on the solid layer, and we're only going to change that object because that's all we need. And so let's see what happens when it collides the wall. Hopefully it'll do what we want it to do, or it'll just avoid the walls altogether because it wants to make a liar out of me. Come on, magic knife. Do your thing. No, come on. No? Okay, it's not colliding whatsoever. Do I have to have it have a rigid body for collision? I don't think so. I thought the circle collider would be enough. Because the solid layers, let's just check out our physics 2D settings here. So solid stuff should collide with other solid stuff. Solid, solid. Yeah. It should be working. However, we don't necessarily have to do it this way. I wonder if it needs to have, I don't think it needs to have a rigid body attached to it. At least I would hope not. So it's not colliding with me either, which is kind of weird because that's what I would expect. Because the player is supposed to collide with solid stuff. So like this ball is a solid object, and the player can, intersect it. But for some reason, these swords don't seem to be solid. Let's see. This trigger. So they're not triggers. Let's just add our rigid body. Which I don't think is the right way to do this because they're not really going to need the kind of physics I'm thinking of. No, still not colliding. How weird. Did I put the collider on the wrong object? No. Move component. Layer solid. Did I not apply it? Maybe I didn't apply it to all the other ones. Oh, there it goes. Now it's pushing the ball around. I guess I just didn't apply it to anything else. So yeah, now I can't collide with it. Which I might change. I might change this to actually just be a trigger for now. See if it'll push me out of the way. Come on. Nope. No. No. Yeah. But let's see if it'll collide with the walls. And to do that, maybe we will just force the direction to be up. So we'll say direction.x is equal to 0 and direction.y is equal to 1, just for testing. Let's get that ball out of there. Oops, no. I have not personally ever used GameMaker, but it's still not colliding with walls. I wonder if it's because we're moving, like, changing the transform itself. I wonder if it has something to do with, let's see if it has a public void on collision enter 2D. This is going to be collision 2D collision, and we'll just do debug.log collided. We'll say with collision.gameObject.name, and we'll check that out. So so it's definitely not colliding with stuff, which is kind of weird. I thought it would collide with the wall colliders at least. Will it collide with me? So yes, it collides with me and it collides with the sports ball, but it doesn't collide with the walls. Is that because, let's see, let's go to the project settings. Oh yes. That's weird. The walls aren't colliding with anything. But yet, these things are walls, if I'm correct, right? They are, okay. So why is the player... Does the player collide with the walls? He does, so... What is going on? Let's see. Oh, because the wall right here. Wall, player, solid, collide with the walls. It is a solid, so it should collide with the walls. Walls should collide with walls, maybe. Maybe not. That's weird. That's really weird. Guy Mr. asks, what's the plot for this one, or are you keeping it a secret? It's not exactly a secret, but we're not going to reveal too much yet. Probably pretty soon, actually, we're going to kind of come out with the kind of the storyline and circumstance around this game, but it's not easy to hide the fact that it takes place in the wizard's house. And so this this sequel, Wizard's Lizard 2, is going to be more centered around the wizard's house and the wizard himself and Raga, as opposed to kind of the cemetery, sewer, crypt locations of the first game. So it's going to be a little bit more, hopefully, focused. You know, we want to really emphasize the wizard-lizard aspects of the game. And so the wizard will be a bigger part of the game as well. So I'm not exactly sure why this isn't doing what I want it to do. With regards to collision in the walls. Because it's on the solid layer, and it's got a circle collider. Let's try giving it a rigid body again and see if it'll collide with the walls. I feel like that shouldn't matter. But let's try it just in case. Get that ball out of there. Nope. Well, no, okay, so it is colliding with the balls now as a rigid body, but if I remove that, is it not colliding with the walls? No, it is not. So for some reason, it has to have the rigid body in order to collide with the walls. That's weird. Yeah. Evan Kurtz asks, do you program and make art? I don't. I only do the programming, and my co-founder, Matt Hackett, does all the artwork for the game. He actually did an art stream last week. I think it was it on Friday? Yeah, it was on Friday. And he was drawing some stuff for the kitchen, actually. So he was drawing a lot of these tables and stuff that you see here, like these tables with the pigs and the turkeys and various other props for the kitchen environment. He was drawing that on our Twitch channel. So if you like that kind of stuff, hopefully we'll be doing that more consistently too. So it looks like we're going to need a rigid body on here for this to work the way I want it to, but that's okay. For now, though, I want to focus on getting the... Basically, I want to cast rays and see how that's going to work, because while it's important that this thing can't move through walls, I think it's actually more important that it kind of preemptively tries not to move into walls, because that is really kind of what I want it to do anyway. Joe says that I make incredible art, asking about my Thanksgiving turkey hunt game. Yes. Actually, I don't know if we have the graphics for that game anywhere anymore. I mean, they're probably buried in Git somewhere. But Matt actually went through and and updated all the graphics. Oh, Joe pasted a link. Let's see. Oh yeah. There's my incredible art. Yeah, like my lopsided pumpkins and my turkeys with no pupils. It ended up just being like a whack-a-mole game. Kind of the context around this was that my wife, Melissa, was working on Thanksgiving, that particular Thanksgiving in 2012. And so I decided I was just going to sit down and make a little game that we could sell. This was back when we were doing web games to license to like mobile web portals. Oh no, 404. That's not good. I'll have to change that later. But anyways, good stuff. I don't know, Joe. I bet you could get to my level. We need a term for Joe art. Jart. It could be like blart. Jart. Or heart. Huckabee art. Yeah. So anyways, excuse me. The next thing we're going to do is I'm going to take this collider out for now because it's not doing exactly what I want anyway. And the next thing is we're going to try and cast some rays, I think. So we could do this either one of two ways. One is we could look at the tile map data, which might be more simple and faster, actually. Also, because this thing moves on the grid, it would be really easy to do that. And that way we wouldn't even have to cast any rays. So that might be kind of fun. Let's see. Oh, thanks for the link, Josen. He pasted a link in chat about a collision matrix and interactions between colliders and rigid bodies. Oh, okay. At least two of the colliding objects need a rigid body. Okay, that makes sense. So yeah, the issue right now, I guess the reason is that the walls are actually just polygon colliders. So if we were to like turn on gizmos here, you can kind of see that the walls are these polygon colliders, and they don't actually have rigid bodies because the walls aren't going to like move. So that is good to know. That makes a lot more sense. Now it doesn't seem like it's just broken. That's good to know. Thank you for that link. Paul Jart Wizard Art. I like that too. Yeah, so Paul Blart, he totally co-opted my term for Blair art. So I had it first. Probably not, actually. Okay, so let's give this a try. I think that the behavior we might want to do here is that it will figure out which directions are possible to move that are not, that don't have a collidable tile in any of those directions, and then it will, of those, choose a random direction until it hits another wall. Although, if we're not detecting the walls, well, I guess the first thing we'll do is we'll check to see if it can move in the current direction, and if it can't, then we'll choose a new direction that isn't blocked. Yeah. Hey, welcome AC Wraith. Thanks for coming as well. Yeah, again, like we were talking about, 90% of programming is Googling stuff. Something else that's really handy for me too is that there's a life cycle. Let's see, so it's like Unity event life cycle. Which is like kind of getting off topic here, but whatever. This is a great page because it kind of keeps track of when all these game object events get fired. So it's like reset, awake, start, the physics stuff happens, then your input, then your game logic, scene rendering, etc., etc., etc. So this is something I look at all the time. Evan says, "Nice hat. Is it a tiger?" Yes, it is. It is one of my tiger hats. I actually have a couple different tiger hats now, but this is my summer tiger hat because it isn't as hot. I have more of a large tiger hat with arms that come down, but it's summertime here in San Diego, and so it's a little too hot to be wearing that. So I picked this up actually at the San Diego Zoo when my wife's family was in town, and we went there. Okay, so let's go back into our script here and let's get rid of some of this stuff just to help us focus. And when we're choosing a direction, we want to choose a direction that is not does not have a collider on it. So I think the way we want this to work is I'm going to go through each of the directions and basically add a vector to a list if those directions are valid. And then we'll just randomly choose one from the list. So what we're going to do here is first we're going to create a list of vector2, and we're going to call this directions, and I'm going to make a new list of vector2 objects. And then we're going to go through, I'll probably just do this in a for loop. Let's see. So we'll say for int y is equal to 0. Actually, this will be -1. And this will be y is less than 2, or I say less than or equal to 1. And then increment y, and then for int x equals -1. X is less than or equal to 1, and then we'll increment, oops, no, it's on L. It's a semicolon. Thank you. So what we want to do here is for each of these directions. Well, first of all, we want to skip the diagonals because we don't want it moving in on a diagonal. Yeah. This is not the tiger hat from the podcast meme. Actually, this is a different tiger hat. The tiger hat from the meme is the one that's in my Twitter picture, which is kind of the bigger one with the arms that come down. That was the original tiger hat. So we're going to say if x is equal to 0, or y is equal to 0, then we're going to continue. Otherwise, it's going to be a diagonal, which we don't want. We're going to test the collider at this tile, and so I think what we're going to do is we're going to look up the sprite tile reference. So sprite tile is the name of the library that we're using for tiling, and I think it's just called get collider. Get collider, there we go. Where'd it go? Is it here? Yes. Okay, so we give it a position, which is an int2, and a layer, which will be 0 by default, and then it will return a boolean telling us if it's a collider or not. So that's good. So we can say if that direction is good, and then we'll say, I guess we'll just create a new int called d, or an int2 rather, and that's going to be a new int2 xy, and then we'll say if tile dot get collider d is true. Actually, in this case, we want it to not be true. I'll probably come back and clean this up because I really hate this, like, pyramid of nesting. We could write this in a slightly different way where we could say, if something, then continue, which is a little bit cleaner in my opinion. But for now, I don't feel like figuring out that logic at the moment. So if the collider, or the direction in question, actually wait, this is not correct yet. The first thing we need is we need the current position. So we're going to have a vector2, which is the position of the object currently. So we'll say position, and this is going to be transform dot position. So the object's position in world space. And then we're going to create an int2, which is going to be the current position dot x plus x, and then the current position dot y plus y. There we go. So this variable d should be giving us the spaces around the entity, tiles around the entity. And so if those are not a collider, we're going to add them. So directions dot add, and then we're just going to say new vector2, and this is going to be d dot x, d dot y. And in the interest of not doing premature optimization, I'm going to keep allocating all these new lists and vectors for the moment. And then once it's kind of working, I would come back and optimize it if I need to. So now that we have a list of the potential directions that are not walls. So let's see if this will actually work. So what we can do is, let's just debug it real quick. So we can say for each vector v in directions, and then we'll just debug dot log v. And okay. Oops, that is a web browser. List one. Okay, a couple things going on here. One, we need system.collections.generic because that is where the generic lists happen to be. And we also need to use sprite tile because sprite tile is going to give us access to that stuff. No, really? Int has some invalid arguments. Really? Is it because, oh, they're floats, right? So we'll just cast those to ints. Another thing we need to do actually is just get rid of this guy. So let's just put him at 0, 0, and then we'll apply any unapplied changes to the prefab, and then we'll delete that. So we don't have two of those guys running around. And so let's pause it real quick. And let's clear it actually, and unpause it. It's a lot of stuff. I think I unpaused it too late. Yeah, okay. It looks to be working because we're only getting a few different things for like 30. So those will be on the x-axis. So it's probably right now at 2962, and 28 and 30 are both open, hopefully. So let's try that. So now that we have this list of vectors that are not colliding, now all we have to do is we can actually get rid of this random direction code, which I'll actually just comment out for now, in case we need it in a second. But theoretically, what we can do is we can say int index is equal to mathf dot, or no, it's going to be unity random dot range, and it's going to be between 0 and the count, which is going to be directions dot count, and then we'll say direction is equal to, oh, actually we don't want to add that. What we want to add here is just x and y, because we actually don't want to add the actual tile that is not collidable. We just want to add the direction in which the tile that is not collidable is going to be, because then down here we can just say direction equals directions index, and then it should go in the direction we think it is. Joe says, oh my god, you have a shortcut for comment out every line. Is that Sublime Text thing? Yes, it is. It's just by default. It's just like in, or command or control, depending. We're in Windows right now, so you hide all the lines you want and just command backslash. We'll just, or forward slash. Will comment out all the lines. So it's very handy. You can also cut lines with Command X, which is very handy. You can also move lines around very easily. Sublime Text is the best. We just changed Joe's life. It's a revelation. Yeah, it's pretty amazing being able to comment large blocks of text out. It changed my life too when I learned about that. So, anyways, let's see if this is actually gonna work. We will not know until we try. Okay, so it's kind of random, but it should never go. You know, it's kind of hard to know, like prove a negative, right? You can't prove that it's not choosing a thing with a wall, but it hasn't yet, so that's pretty good. I think what we want to do to make this a little less erratic is, instead of just choosing a random direction, the thing we want to do is we want to default it to some direction. So in this case, let's just change this to be it's going to the right by default. So it'll want to go to the right by default, and then when it's going to choose a direction, first we're going to see if, so if tile.getCollider, and we're going to have to create an int2 again. So int2 p is equal to new int2, and this is going to be pos.x plus direction.x, and then pos.y plus direction.y. And so this is going to give us the current heading. And so we're going to say if that is a collider, then we'll do all this stuff here. So we'll just grab that and put it in there. And it didn't indent correctly because it hates me, but that's fine. Yeah, so theoretically what should happen here is that if the tile on its current heading is going the direction that is not a collider, then it'll just keep going. And so we have errors. No. All right, we gotta cast these things to ints again. No. Okay, this time it'll work, I promise. Maybe? No. Really? Int, PS, what are you talking about? Seems to work down here. POS. So this is going to be a float. That's going to be a float. Oh, maybe it's because it's converting. Yeah. It's like taking the int. Just add some parentheses here. Oops. Yeah, Sublime Text is amazing. I've been using it for years and years and years for web development, and I like it. I haven't really tried monodevelop, to be honest. I haven't really given it a fair shot. So it's going to start going to the right, to the sword. And when it hits this, yes, it should turn around. Yes. Awesome. And then it should just go on this path for a while. Let's grab that ball. Shoot it out of here. Hey, wait. What are you doing? Get out of here. Ball. Go that way. Man, must be hitting some walls. We'll drop it over there. So it shouldn't always just pick back and forth. Yes, that's going to go down. Awesome. Now it's going to go that way. I think the next thing we might want to do is make it so that it never picks 180 degrees behind itself. So I think what we could do here is say if x or y 0, and then we can say if x is equal to negative position dot x, if x is not equal to 0 and direction dot x, negative direction dot x is equal to x, or this is going to be kind of some complicated logic here, but the gist of it is that we want, let's say, or y is not equal to 0 and negative direction dot y is equal to y. Basically, what we're saying here is that we don't want to go in the complete opposite direction of the direction that we were currently heading. So we only want to pick, although the problem with that approach is that if there aren't any other directions to go but backwards, like let's say it goes into a a place where there's only one direction to come out of, then that can be a problem. So we're actually not going to do it that way. I think what we want to do is before we randomize it, maybe we want to go for each direction, let's be vector 2, in directions, and then here we can say if direction dot x is not equal to 0, and the current direction, what do I say, and direction dot, or dir dot x is equal to negative direction dot x. Or direction dot y is not equal to 0, and direction dot y is equal to negative direction dot y. Then we want to remove this guy. So we'll say, well, we only want to do this if the count is greater than 1. So if directions.count is greater than 1, then do all this stuff. And then, what? Oh no, there we go. Then we're going to say directions dot remove direction. So let's add some comments here. Remove the opposite direction from the pool if more than one option exists. And so hopefully the effect there will be that if it gets trapped in a dead end and it can only go back the way it came, it will do so, but otherwise it will prefer not to do that. And we have an error. Oh, directions. It's probably naming things very similarly. Let's see. Yeah, data manipulation in Sublime Text is really easy. It's just very, you know, it's kind of a bare bones. I mean, not really bare bones. There's a lot of functionality there, but oh, we have an error. It's just meant for manipulating text. That's why, you know, I think it's kind of better than some of these more full-fledged IDEs like MonoDevelop and stuff. Guy Mr. asks if it's possible to lick the sword and shoot it out as a projectile like the ball. Yes, it is possible. It just, the collision stuff doesn't work at this moment that way. But we actually have plans to make all of the projectiles lickable, I guess you could say, so that you know, if you're fighting some stuff and it shoots a bullet or a sword or whatever at you, you can tongue it out of the air, grab it, and spit it back out of it. So that's going to be kind of fundamental to the gameplay. Let's see. Yeah, no, I really like a lot of stuff. I think that there's a lot of room to harmonize with the tongue abilities there. You know, you could have projectiles that when you put them in your mouth, they do damage to you, but they're extremely powerful. And so you could kind of make that trade-off between, do I want to take a hit of damage but be able to just really destroy this certain thing, or something along those lines. Anyways, we got an error here. Collection was modified. Enumeration option may not execute. Okay. So we can't just remove it on the fly. The good thing about this is that we actually don't need to keep going. I wonder if we can just break, and if that will do what we want. Because there's only going to be one opposite direction, obviously. And so if we find it and we remove it, then we don't need to continue iterating anyway. Yep, that works nice. You fail me, sword. Let's speed this guy up just a little bit. So that's, let's say it's going to take him only 2.5, and then choose a direction in 0.5. I'll probably mess up the timing a little bit, but wants to be a little bit faster while we're debugging it. So he goes up. You see, you're not supposed to choose that, sword. You're not supposed to choose that direction. Excuse me. Yeah, roguelikes are all about risk versus reward, so that's definitely an avenue that I want to exploit there. Having to basically resource trade, right? Like, do you want to trade your health resource for this other resource, which could be more damage or a special ability or, what have you. So this isn't exactly working the way we wanted it to work. So it breaks out of the for each, theoretically, if it removes that direction. Maybe our logic here is just not as good as I think it is. Because, yeah, without that stuff, it doesn't get stuck in the corners. It could potentially go all the way. No, I guess it does. Huh. So let's... Maybe that is not the problem. Is it because we changed the timing of stuff? Because we're invoking these functions a little faster than we used to? Let's try moving these things back to how they were before. Sort of the problem with tweening stuff sometimes is that you can kind of overlap stuff, and if you're kind of hanging all of your handler functions on the end of tweens, things can get kind of messed up. No, it still gets messed up. So now it's time to actually look. Debug.log, and let's debug the direction. And we'll also debug.log up here. So we'll debug.log. We'll say choices is going to be directions.count. And then the direction that it picked. Put that up here too. We don't need to do that all the time. So it hasn't changed directions yet, so it's just going to keep going. So now it picked the opposite direction. I don't know what that button does. But we'll just check it out and see what's going on. Shoot. Hey. Whee! Play ball with myself. There we go. So it's going to pick down. It's going to pick up. It's interesting how the movement isn't the same every single tile frame, because the kind of the floating motion is a little bit out of sync with the tile movement. Probably sync that up better in the future. Let's see. 0, 0. Okay, so we found the problem. The problem is that it's choosing to go to 0, 0, which it really shouldn't. So let's fix that real quick. Excuse me. Why would it be doing that? Because theoretically, if x or y is equal to 0, then it would not do that. So let's debug.log x plus y. You know what I kind of miss about this in Unity, and I don't know if there's a way to do this, is that in like the JavaScript console, I could say like console.log x comma y, and it would just log those two parameters instead of having to actually string concatenate, with some kind of separator. There's probably a way to do it. Or maybe there isn't. Maybe it's not as common as I think. So let's just see. Theoretically, if this is a problem, we should always be seeing 0, 0 in our list of things that are possible. So it just, yeah, let's pause it. So let's see. There were 3 choices, one of which was 0, 0. Oh, I know it. God. I don't know why I didn't see this before. Yes, so actually what we want to use here is exclusive OR. So let's see, sharp, whoops, C sharp, exclusive OR. Right, it's the caret. Okay, great. The heck. Anyways, the exclusive OR means only one of the 2 is true. So that way we don't get the 0, 0 coordinate. We're only going to get a case where either x or y, exclusive or y, is 0. Which will then, kind of make sure that it's always going in an orthogonal direction and never not a direction, which is the 0, 0. Because that kind of makes it just completely stop. So I'm not seeing, this looks pretty good so far. So I guess this corner will have 2 choices. And it picks the top. Okay. So now that we fixed that bug, let's go back in here and we'll uncommon out our preference for not making a complete 180. So when it gets to this wall on the right here, sorry this is a little slow, I hope it's not that boring, but when it gets to this wall right here, it should either go left or right, relative to itself. And then when it gets to this one, it should either go, in this case it should go left almost all the time because it's gonna, yeah, there you go. So the only problem with this method now, like, as we're watching this play out, you're going to see that it's basically just going to always choose to like follow the walls because it's never going to choose to turn around completely. And so the thing we could do is we could also just say if you've made like a certain number of moves in the current direction, then we want to try and change directions as well to something else. Because right now it's just kind of going to walk the outsides of the room, which is not, I mean, it could be an interesting behavior, but I don't know that it's exactly what we want for this particular thing. Joe says you can use debug log format, multiple params, but you have to get a format string, sort of like printf. Some people have written their own replacements, which was like cool. Oh, cool. Thanks, Joe. I will definitely have to check that out because that'll be really handy. So I think we can get rid of this logging, some of this logging for the moment. And maybe just clean this up just a tad. And I think it's time to get rid of this guy. Oops. And so maybe let's add a basically a counter here. We'll call it direction count. And so start at 0. And every time that we move, yes, we can just iterate on that. So we can say plus plus direction count. And then here we can say if direction count is greater than, let's say 3, or tile collider is collider, then we'll just also reset the collider direction count is equal to 0. So theoretically, the way that should work is that every 4th space, yep, it can choose to change direction. We could also modify the logic to make it so that it always chooses to change direction at that many spaces, or we could make it a random number of spaces every time it changes. So it could be like it goes, 3 to 4 spaces. But this is a little more interesting now because at least it moves around in a slightly less predictable manner. That's pretty good. I'm kind of liking that. That's good stuff. That's going to work for now, I think. Definitely made a lot of progress on that guy. That was pretty fun. I think what we'll do, just real quick, is we can go in here. So let's grab our knife and put it here for now, and then let's just add a circle collider back to it. Actually, a circle collider is probably not the best idea for this guy. Let's remove that and add a box collider. Well, no, because the box isn't going to rotate because the sprite is actually what's rotating. So we'll just keep a circle collider for now, even though it's not exactly what we want. But hey, that's good enough for now. It's good enough for testing. And then we'll add our hazard script to this, which is going to do damage to the player. And then I think that's, oops, no. And then we're going to make this a trigger. Sword hype, yeah. Oh no, it's not colliding with the player. I think we just have to check out the hazard component. Apply damage. Yes, it should be working. So if it's colliding with the player, it should be applying damage to the game object on trigger enter 2D. So it's a trigger, and it is solid, which collides with the player. Well, we'll have to figure that out. Because I feel like that should... Oh, I know why. God, I'm dumb. We need to apply that to the other prefabs because we're instantiating these prefabs on the fly. And then I always forget when I make changes to prefabs that I just kind of drag onto the inspector that they don't pick it up. There we go. Ow. Screen shake. Ow. Why are you hurting me? You mean magical sword. Game over. Hooray! There we go. So that was pretty cool. About an hour and 45 minutes, we ended up with a pretty cool looking sword, magical sword that flies around and has cool particles and does damage to the player and kind of has some sort of interesting movement. You can imagine if there's more of these all over the house, which we can just test out real quick. Let's open up our kitchen data file, and then again we're going to go in here and we'll just take out these guys, and then we'll add an entry for traps, knife, and now there we go. We got swords all over the place. Magic swords, look at that. That's fun. Let's see where these guys are going to go. Oh, these guys are kind of, oh, there they go. Now they're a little bit off sync. So that's pretty fun. Already now it's a little bit more interesting to navigate this area because, oh, we got two swords on top of each other. It would be kind of cool if I could prevent them from overlapping with other entities. So that might be the next step. I think that will have to be some kind of ray tracing. I mean, it'll basically be the same algorithm, but instead of looking at the tile data for collision, we can just cast a ray into the next adjoining cell and make sure that we're not going to hit something else. So awesome, good stuff. I think that's going to be it for me tonight. That feels like a good place to stop. I think that I'll probably refine that over the course of the next week, and maybe we'll tackle some more advanced stuff with that enemy, or or other enemies next week. So thanks everybody for attending. It's been fun. I always love doing this stuff. So thank you very much for joining us. If you have your thoughts, let me know either on Twitter, twitter.com/Geoff Blair, GeoffBlair. Or you can always come join us on the Lost Decade Games community forum, which is forum.lostdecadegames.com. Anyways, thanks everybody, and I will see you next week. Ship it.